Good morning. Our project involves the transport and reduction of sea salt. The efficient handling of solid materials on sea salts required transport lifting and sea salt reduction system. This project presents the internet design of a commonly belt, a vaulting elevator, and particle reduction equipment, along with an analysis for pneumatic transport and an alternative. Operation parameters, equipment settings, and comparison are established to ensure a reliability and operations process. In this diagram, we see more especially how salt in the transport using conveyor belts, buckets, and pipes, which carry the proofs from a hopper to the container.
In this slide, we calculate the width of the camera weight using the flow rated the 50 tons per hour and the material properties of the salt. We first estimate and the initial well speed. With these values, we calculate the total volume. The well was moved and applying the formula determined the required well depth. The result was approximately 0.37 meters, which corresponded to commercial belt width of the 40 centimeters. After that, using this width, we check the reference table for recommended wheel speed and selected a final operating speed of the 1 meter per second with ensures accounting. Use an stable flow without splits. In this slide, we first calculate the well tensions. We converted the flow rate obtained the mass per meter of the material and the weld and use that to calculate the friction force. Then we determined the difference with the tight side and the slide side tensions to ensure the weld does not slip. Next, we calculate the motor power using method 2. With the weight the meter, we obtain P's and the PA and the PH is 0 because the conversion is horizontal. Finally, we added this and applied the efficiency, giving a total power PW of about 9.5 hours powers. This system is composed by the support structure and the loading and unloading components. This support structure includes the longitudinal beams, the crossbar members, the length and width under anchors, and the mounting and fitting plate. For the loading and the loading system, the process works by gravity. The salt falls onto the well, then enters the buckets. The buckets discharge the material by gravity into the core hopper. The system also includes safety devices, an emergency stop button, and the buoying and the end of the welt and the speed indicator.
In the buckets, we first calculation the drive power using in the initial date of tons and heavy, of which in the locage result in 32.9. In the support system, the elevator consists of an belt of chain to which in the buckets then transport the material of attached. The support system ensures that the belt remains taut, alleged, and coupled and support the weight on the material on the buckets themselves during on the cycle. In the loading and holding system, we find that the salt falls directly from the conveyor field on the lower open of the elevator. The box will passes through this area, entering the oven, and the bucket is feeling the gravity due to the uniform ball down material. The material retains inside the bucket throws down the entire hopping to the top. When the buckets ring the overdrive pulley, the rotation of the belts causes the buckets to really invert to the converse around the pulley, and the material is automatically really deep gravity on the next belly. Softening of the unclosed immigration buried on the button on the top on the lever to speed detector fill the sensor to the better interior from exceeds the capacity of the bucket. Finally, wears in the metal covers the prevent strap forming.
Next, we have the crusher selection. First, we decide to achieve the correct particle size reduction. We decide to create a comparative table evaluating roller and hammer crusher. This led us to conclude that the roller crusher was adjusted to its low energy and cost consumption, as well as the ability to efficiently break down salt particles. Next, we have the sizing. Uh, in order to obtain the apparent density value of the system after the 1 to 10 particular reduction, the capturing was performing using the policy range obtained for the literature. This way done to analyze how the grading process and its distribution through a hopper connected to the pneumatic conveying system after the density. With the obtained density value, we can proceed with the calculation, the hopper obtaining, and the total health of the grading system. This calculation is performed in the same way as the silo side. After the preliminary calculation, two crucial values need to be determined: work and power. Work was calculated using the Rittinger's law, which is used for reducing medium-sized particles. Once this work value is calculated, the crusher capacity is simply multiplied by the work value to obtain the equipment power.
When we talk about pneumatic combining, we need some data to identify the losses in our piping system and how we can mitigate them. To do this, we need to find the setting velocity, which is 27.1, and the submersion velocity, which is 13.1. These values will help us determine the fluidity of our solid and whether it should be diluted or not. In this case, we see that the losses in the vertical section and the horizontal section it's the same data. To determine the required flow rate for the blower, we need to know the diameter of our pipe. Several tests we conducted and we determined that 3.17 inches was the best diameter due to the fluidization. It proved. Once we obtained the flow rate of 0.1, we could calculate the blower's power requirements. Additionally, we need to know that a cyclone separator is the best method for separating our solid material from the dry air, and that our blower should have a power rating of 169.6 kilowatts. In conclusions, when we have a solid hauling system, we have combine both mechanical and pneumatic transport methods to optimize the process. Second one, crushing helps transport the solid in other way because when they are very large, it becomes more complex. And final one, it's important to know that every system will always have losses, but and we have the most know how to mitigate them. Thank you.